This week, we're doing a deep dive into a really fascinating cosmic visitor, one that kind of defied expectations, sparked a lot of headlines, and, well, gave astronomers quite the puzzle.
Yeah, we're talking about 3I Atlas.
Exactly, 3I Atlas. It's been a source of some amazing science, but also, some pretty intense speculation. We've got a good stack of sources covering its, frankly, bizarre behavior, its shocking makeup, and, yeah, the controversy it kicked off.
It really is the perfect topic for this kind of discussion. It forced this balancing act, right, between these really dramatic possibilities and just rigorous, hard observation.
And that 3I addingation is key here, isn't it?
Oh, absolutely. It stands for the third interstellar object. That means only the third one officially documented by the International Astronomical Union that we know came from outside our solar system.
Only the third one we've ever tracked passing through. So like you said, a genuine messenger from somewhere else entirely. So our mission today, pretty straightforward. Let's unpack the facts about this rare visitor, really get into its unique composition, and impartially look at that whole high-profile, is it tech debate it fueled.
And what's so fascinating, just scientifically, is the value of these interstellar objects, or IOs. I mean, think about it. They're the only physical things we can observe right here in our backyard, so to speak, that actually started somewhere else.
Right, like samples delivered to our doorstep.
Pretty much. They give us this unique window into what researchers often call pristine material from other star systems. Basically, a little piece of whatever other solar systems are built from.
And 3I Atlas, it was pretty quickly confirmed as a comet, wasn't it? Though maybe not a typical one.
Correct. It got the comet designation.
Yeah.
But let's set the baseline. Like, what is a typical comet from our own solar system?
Okay, yeah. Usually they're super dark, right? These icy bodies, really hard to spot until they swing in close to the sun.
That's the crucial point. It's the sun's heat, the solar radiation that normally does the work. It heats the comet, makes those volatile ices, mostly water ice in our comets, turn to gas, and that creates the fuzzy cloud, the coma, and eventually the tail.
And that usually happens inside Jupiter's orbit.
Generally, yeah. You typically need to get closer than Jupiter, maybe around 5 times the Earth-Sun distance, 5 astronomical units or AU, for the sun to be intense enough to really kickstart that process for a water ice-dominated comet.
Okay, so that's the rule book.
That's the standard playbook.
And 3I Atlas just ripped that page out.
It really did, spectacularly. Right from its discovery back in July, astronomers knew something was off.
How so?
It was already outgassing. It was generating its own visible coma when it was still way out there, at 6.4 AU from the sun. That's well beyond Jupiter's orbit.
6.4 AU. Okay, so much further out than the usual ignition point.
Significantly further. It was defying the sort of expected thermal limits for a standard comet. Way too cold out there, theoretically, for that much activity if it were just made of water ice like our usual suspects.
So that glow, that abnormal activity so far from the sun's warmth, it meant it had to be actively producing light and gas when, by rights, it should have been pretty dormant.
Exactly. And for some people, well, that immediately set off alarm bells or maybe speculation klaxons.
Yeah. If it's not supposed to be glowing, but it is.
Right. If you see something relatively small, moving fast, making its own light, showing activity where it shouldn't, the, let's say, more exotic thinking kicks in. Could it be technological? Is it powered somehow rather than just passively reacting to the sun? That was the initial leap that really fueled those early alien spacecraft ideas.
And the speculation got pretty intense for a bit there.
It did, but that early anomaly, that glowing too soon, was only part of the picture. Subsequent observations pretty quickly actually confirmed it did have a comet-like tail.
Ah, okay, so still acting like a comet in that way.
Yeah, which strongly suggested a natural origin, but one that needed a non-standard explanation. The anomaly was real, but maybe the explanation wasn't aliens.
And that's where the big guns came in, specifically the James Webb Space Telescope.
Precisely. JWST was tasked with doing that deep dive into its actual composition. What is this thing made of? And it found the answer to why it started glowing so far out.
Which was?
It turns out it was incredibly rich in carbon dioxide, CO2 ice. Dry ice.
Dry ice, okay.
And dry ice turns straight to gas sublimates much, much more easily than water ice.
Yeah.
It doesn't need nearly as much heat. So that explained the premature activity. It wasn't defying physics. It just had a different, more volatile ingredient list.
It's amazing we can get that kind of detailed chemical fingerprint from something that far away just visiting.
Isn't it? JWST is incredible. But here's the kicker. It wasn't just some CO2. The amount was, it was astonishing.
Astonishing.
The ratio. The data showed 3I Atlas has a carbon dioxide ice-to-water ice ratio of about 8 to 1.
8 parts CO2 ice for every 1 part water ice.
Exactly, 8 to 1. That is one of the highest CO2 ratios ever recorded in any comet, interstellar or otherwise.
Wow. Okay, that fundamentally changes things, doesn't it? Our comets are mostly water ice.
It really challenges our basic assumption, or maybe our observation, that water ice is the dominant building block for these icy bodies everywhere. This visitor suggests maybe not.
So what does that tell us, this super high CO2 ratio? What does it imply about where 3I Atlas came from, its home system?
It gives us a really specific fingerprint of its birth environment. This kind of composition suggests its parent system, which, based on its trajectory, probably originated deep in the Milky Way bulge before getting kicked out by some strong gravitational interaction, a perturbation.
Okay.
That system was either just naturally really, really rich in carbon dioxide, much more so than ours, or maybe it formed under, I don't know, weird radiation processes, as the source material put it. Conditions very different from the ones that formed our planets and comets.
So a glimpse into potentially much colder, carbon-heavy solar system nurseries out there.
That's the takeaway. A snapshot suggesting other systems might form in environments dramatically different from ours.
Okay, so we have this picture now. A very unusual CO2-loaded interstellar comet, but we absolutely cannot talk about 3 Atlas without tackling the elephant in the room, right? The headline grabber.
Hey, yeah, the alien mothership hypothesis. We have to go there.
We do. It was championed quite publicly by Harvard professor Avi Loeb.
Right. And this raises an interesting point about, scientific rigor versus pushing boundaries, maybe pedagogical exploration. Loeb really framed it as a possibility, a thought experiment worth testing. He didn't say it was aliens, but he suggested the object might not be natural.
He assigned odds, didn't he? I remember reading something like,
Yeah, he put a 30–40% likelihood on it being what he called a black swan event akin to a Trojan horse, which, in scientific terms, is a pretty high probability to assign to something so extraordinary without direct evidence.
30 to 40%. Yeah, that definitely gets your attention. And this whole hypothesis kind of came to a head recently because of where the object was going in our solar system.
That's right. Timing was everything for this test. The object recently passed behind the sun from our viewpoint. That's called solar conjunction. That happened around October 21st. Then it reached its closest point to the sun, perihelion, on October 29th.
So basically hidden from Earth's direct view for a crucial period.
Exactly. And the argument, Loeb's argument, hinged on that timing. The hypothesis was, if this were some kind of alien technology, this period of invisibility would be the perfect time to perform a significant maneuver without us seeing it happen.
Okay, and the specific maneuver mentioned was the Oberth maneuver. What is that exactly?
It's a known concept in rocketry and orbital mechanics. Basically, it's the most fuel-efficient way to change your velocity. You perform your engine burn when you're deepest in a gravity, well, in this case, right near the sun at perihelion. The sun's gravity amplifies the effect of your thrust.
So use the sun's gravity to get more bang for your buck, engine-wise.
Precisely. So the idea was an alien probe could use this Oberth maneuver, well, hidden by the sun, to dramatically change its course or speed, perhaps to slow down.
Slow down, maybe to stick around. Or intercept Earth.
That was the implication in one scenario. The other variation proposed was maybe a mothership releasing smaller probes. It could perform a reverse Oberth maneuver again, hidden from view to shed velocity, and slow down enough so that it, or the probes, might end up closer to Earth's orbit within a few months.
Okay, that would require a really noticeable change in its path, its momentum, once we could see it again.
A distinct, measurable change. Absolutely. That was the core of the testable prediction.
It's a wild idea, undeniably fascinating. But we have to bring in the scientific consensus here. How did the broader astronomical community view this?
Well, the consensus has been pretty firm, leaning heavily on Occam's razor. The simplest explanation that fits the data is usually the best.
Which in this case was?
That it's a natural, albeit weird, comet. Tom Statler, who's NASA's lead scientist for solar system small bodies, summed it up really well. He basically said, it looks like a comet. It does comet things.
Simple as that.
Pretty much. He added that the evidence is overwhelmingly pointing to this object being a natural body. The weird glow wasn't evidence of technology. It was evidence of its unusual composition, that high CO2 content. That explained the early activity without needing aliens.
So the object going behind the sun and hitting perihelion wasn't just a potential hiding spot for aliens. It was actually the ultimate test of that hypothesis.
Exactly. Now that it's emerging, we can see if the prediction holds up.
And what would confirm or deny it? What are scientists looking for now?
It's pretty straightforward. If it had performed some kind of engine burn or released probes, we would see, and I quote, unexpected and unexplained changes to the object's trajectory and mass as it comes back into view.
Meaning it wouldn't be quite where we expected it to be or moving at the speed we expected.
Right. If it's just a natural comet, its path will change slightly. Comets do get pushed around a bit by the sun's heat and their own outgassing, but those changes would be small, predictable, based on its composition and solar exposure. Nothing like the dramatic shift needed for an over-Earth maneuver or intercept course.
So the key now is just precision tracking. Measure its path, measure its speed, and see if it matches the natural comet model or the hidden maneuver model.
That's the test. And all indications so far point towards the natural model holding up.
Okay, so connecting this back out, assuming it is just a very interesting comet, its journey out of the solar system now gives us another chance to learn, right? Especially since you said all that volatile CO2 has likely boiled off near the sun.
Yes, this next phase is actually scientifically crucial. As 3I Atlas heads back out, past Jupiter's orbit again, there's a spacecraft out there perfectly positioned to get a good look.
Which one?
The Juno satellite, which is currently orbiting Jupiter. It'll have the best vantage point as the comet recedes.
And why is that timing so important, seeing it after perihelion?
Because, as you said, it's been sandblasted by the sun. That highly volatile CO2 mantle or surface layer has largely sublimated away, boiled off. So what Juno might get to see is, well, what's left?
The core, the actual guts of this interstellar visitor.
Potentially. Scientists hope to get a look at the more pristine, refractory core structure underneath, figure out its true density, what heavier, less volatile materials make it up. That kind of insight into the heart of an interstellar object, that's gold dust. We can't get that any other way right now.
So this whole episode, the drama, the debate, it ultimately brings us back to the fundamental science, doesn't it? Regardless of the mothership talk, 3I Atlas is helping us refine our understanding of how solar systems form.
Absolutely. It's the ultimate yardstick, in a way. It's a pure physical sample, a window into the actual building blocks of other systems. It's incredibly precious data.
And the big so what for you listening. Why should you care about the CO2 ratio of a tiny speck visiting from light years away?
Well, analyzing 3I Atlas, and objects like it, helps us tackle a really fundamental question. Is our solar system, with its setup, its abundance of liquid water, the conditions that allowed for life as we know it, is this setup common, or is it actually quite rare?
We tend to just assume we're average, don't we? That other systems probably look kind of like ours.
It's a natural bias. But the data we're getting from sources, reinforced by just how different 3I Atlas is, it suggests our system seems to be relatively rare.
And this comet helps quantify that.
In a way, yes. The fact that this visitor carries such an extreme CO2 to water ice ratio, so fundamentally different from the stuff-building comets here, it does kind of reinforce that idea. This carbon-rich, volatile, heavy composition might be more typical out there, helping us understand just how unique, perhaps, the specific recipe was that cooked up Earth and life here.
That is fascinating. So, okay, let's recap. We started with this bizarre glowing object way out past Jupiter. We followed the intellectual roller coaster. Really, is it an alien ship? Is it just a weird comet? And we landed on confirmation. It's a highly volatile, CO2-packed messenger from interstellar space.
And one that's giving us critical clues about how planetary systems might form elsewhere in the galaxy.
Even though the alien hypothesis grabbed the headlines, you're saying the natural explanation is actually scientifically just as profound.
Oh, absolutely. It offers this incredible, granular insight into the raw materials of the cosmos, the stuff that builds worlds. It refines what we know about the conditions out there.
Okay, so here's a final thought for you to chew on, building on that. If 3I Atlas, with its weird, dry, ice-rich composition, is maybe more typical of the raw materials floating between stars, does that make the abundance of water we see in our solar system the real anomaly?
That's a great question to ponder.
And if our watery setup is the rare exception, does the sheer strangeness of 3I Atlas actually reinforce the idea that the conditions needed for life, like ours are, statistically speaking, an even bigger cosmic lottery win than we thought?
It certainly makes you think about the odds and what defines normal out there.
What kind of rare or maybe common composition will the next interstellar visitor bring us? Something to watch for. Thanks for diving deep with us today.